Next structural member is column. Column is a compression member. These are all the dimensions of columns: length, breadth and depth. Length is the distance between floor to floor. So we know how many floors we are going to construct and what is the floor height. So from that we can find out the length of the column. But we need to find out the depth and breadth of the column. So how do we find that? So let's learn from this video. Before finding out the breadth and depth of the column, we have to find out the load coming on the column. So let's estimate the load on column by thumb rule. It is an approximate method. So by arriving the load on the column, we can arrive the size of the column, like breadth and depth of the column. So by using the breadth and depth, we can start analyzing the structure. So after that we can come to know how much load exactly is coming, whether the column is able to carry the load or not. If the column is not failing, then we can go ahead with the size whatever we have taken from this approximate method. If the column is failing, then we have to change the size of the column and then redo the analysis procedure. So let me tell you how do we calculate the load on column. Load on column is equal to number of floors multiplied by tributary area of column into load per meter squared per floor. So this is the formula to arrive the load on column. We have thumb rule for load per meter squared for columns, that is for residential building as well as commercial building. According to the column position, we'll be having only 3 column position, whether the column must be interior column or side or end column or corner column. So these 3 positions we will be having. So for interior column, residential building, it is 12 kilonewton per meter squared. Commercial building, it is 14 kilonewton per meter squared. Side or end columns, for residential building, it is 17 kilonewton per meter squared. Commercial building, 19 kilonewton per meter squared. At last, corner columns, for residential building, it is 22 kilonewton per meter squared. For commercial building, it is 24 kilonewton per meter squared. In addition to that, add 2 kilonewton per meter squared extra in toilet and staircase areas. So while calculating the load, we have to add 2 kilonewton per meter squared extra in toilet and staircase areas. For an example, consider G plus 3 floors. That means overall 4 floors. The slab panel is 4.5 meter by 4.5 meter. Interior column. Load on interior column we are going to calculate now, which is equal to number of floors multiplied by tributary area of column multiplied by load per meter squared per. Before proceeding with the calculation, let me explain you what is the tributary area of column. In this column layout, consider this column C6. So this area, the shaded area, is the tributary area of this column. That means this portion of the load will come to this column. Center to center of the column we have to consider, and then we have to find out this tributary area of the column. For example, if you consider C3 column, so this is the tributary area of this column. Similarly, if you consider this C4 column, so this is the tributary area of this column. So this is how you need to find out the tributary area. Let me show you another column layout. Here for C2, this is the tributary area. For C3, this is the tributary area. That means like from C3 to C6 we need to find, and in between there is one C4 also. So we have to find this tributary area according to the center to center distance of the column. We took the example of G plus 3 floors and the slab panel is 4.5 meter by 4.5 meter. That is also interior panel like this. If it is an interior panel, consider this C4 column. The interior panel look like this. So this is our tributary area for C4 column. Now we know what is tributary area of column. Number of floors are G plus 3, that is 4 floors, and tributary area is 4.5 by 4.5. and 12 kilonewton per meter squared is the load, which is for residential building. So by solving this we get 972 kilonewton. Column load is 972 kilonewton. Ultimate load we need to find out. 1.5 is the factor of safety. So that multiplied by the column load, which gives you ultimate load, that is 1458 kilonewton. From this we need to find out the area. Here the ultimate load is multiplied with 90. How we get this 90? As I told you before, gross area required is equal to 80 to 100 millimeter square per every 1 kilonewton of ultimate load carried by the column. So each 1 kilonewton of ultimate load we need to consider 80 to 100 mm squared of area. So that's why here I took 90 mm squared. So if we multiply that 90 with the ultimate load, we get the area required. So that comes around 1,31,220 millimeter square. And area is equal to breadth into depth. From that we can arrive this depth is equal to area divided divided by breadth. Minimum width we need to consider 200 mm. So here I have taken as 230 mm. From this we can find out the depth, that comes around 570.52 millimeter. So we can round it off as a 600 mm. Column size is 230 by 600. We know the column size now. Now we need to find out the steel area. Minimum percentage of steel for column is 0.8% as per IS 456-2000. Class number 26.5.3. So here it is given as the cross-sectional area of longitudinal reinforcement shall not be less than 0.8%. So minimum we need to provide 0.8%. Here I have assumed as 1% of steel and M25 grade of concrete. So 1.5% of steel means how much area will come? Area of steel, that is 2070 mm square. So this is how we need to calculate that 1.5 divided by 100 multiplied by the area of concrete. So we get the steel area. Steel area is 2070 mm square. Now we need to provide the number of bars. So we can split that one into 4 number of 20 mm bar and 4 number of 16 mm dia bar. 4T20 and 4T16 as a longitudinal reinforcement. Next we need to find out the safe load carrying capacity of column. As per IS 456-2000, the formula is PU is equal to 0.4 FCK AC plus 0.67 FY ASC. So class number 39.3 it is given. Here PU is the axial load on member, FCK is the characteristic compressive strength of concrete, and AC is the area of concrete. FY is the characteristic strength of compression reinforcement, and ASC is the area of longitudinal reinforcement for columns. Grade of steel, that is the characteristic strength of compression reinforcement, is 415 Newton per millimeter square. Now let's apply all the values in this formula. First we need to find out the area of concrete. Area of concrete is equal to gross area minus the steel area. So gross area is 230 by 600, that is area of the column, minus 4 multiplied by 314, that is area of 20 mm dia bar, plus 4 multiplied by 201, that is area of 16 mm dia bar. So we get 1,37,548 mm square. Let's apply this one in the formula. 0.4 multiplied by FCK is 25 and AC is area of concrete 137,548 plus 0.67 FY is 415, that is grade of steel, multiplied by the area of steel, area of compression reinforcement, that is 2070 divided by 1000. So we get the PU as 1951.04 kilonewton, which is greater than 1458 kilonewton. Hence it is safe. Column size is 230 by 600 mm. This column size can safely carry the load of 1951 kilonewton, which is more than the load whichever we have calculated as per the thumb rule. So this is the method of how to calculate the initial size of the column and how to calculate the safe load carrying capacity of the column. So this is only one method. We have other few methods as well. Those things I will attach you along with this video as a PDF file. If you want to refer that, you can refer for further clarifications. And friends, that's all about this video. We will meet in the next video.